Feature Labs has its roots at MIT. Prior to starting Feature Labs, I was a student and machine learning researcher at MIT's Computer Science and Artificial Intelligence Lab. I worked in a group with Kalyan Veramachanini that focused on building tools for applied machine learning and data science. The group was particularly interesting because we worked with industry sponsors on real-world problems. While we were working on the problems, we had access to a diverse range of industries and data sets that we could do our research on. What we found while we were working on that was that our biggest challenge wasn't building accurate machine learning models, but rather at the time it took us to get to those solutions. While we were working on those problems, we used every tool available from us. This ranged from databases and ways of storing and warehousing our data to using open source technologies for machine learning. However, in between those two things, we realized there was a gap. And this gap was all the work that data scientists do to transform and extract the features from their data that make the machine learning models work. As engineers ourselves, we knew there was a better way, and I focused my graduate research on building that better way. In 2015, we published the results of our research on an algorithm called deep feature synthesis. We were blown away by the interest that industry had on it, and we ended up getting published in over 200 publications around the world. At that point, me and Kalyan started Feature Labs so that we could bring that powerful technology to the market and help every company use machine learning. The biggest problem with machine learning today is not that it doesn't work, but that companies struggle to use it. Feature Labs recommends for any company trying to apply machine learning that they develop a structured and repeatable process for going from raw data to their predictive model. To support this process, one of the most important things to have is the right tools. Beyond that, it's important to approach these projects not as research projects, but as actual deployable products that you want to create. Too often we see companies start a machine learning project and end with a PowerPoint presentation or a research paper. If machine learning is going to have an impact for companies, they need to focus on deploying those models and actually seeing real results. This is why having a structured process and the correct tooling is really important, because it enables them to take the code they wrote in development and put it into production. One of the biggest keys to success we've seen across our customers is taking the people who understand the domain that they're working on and getting them involved in the process. This is because it doesn't matter how accurate your model is if it doesn't solve a real problem for the business. By using automation technology, we can lower the bar to entry for domain experts and companies to get involved with machine learning. One of the best ways a company can build their first machine learning model is by focusing on the quickest path to value. Oftentimes, this means not starting with the state-of-the-art technology, but instead focusing on building that first simple model that you can deploy. Automation technology helps us with this because it reduces the time to building that first model, validating the use case, and actually quantifying the importance of accuracy improvements. Based on our experience with our customers, we developed Machine Learning 2.0, which is a new paradigm for developing and creating new machine learning products and services. Machine Learning 2.0 is a set of 7 steps that enterprises can follow to go from raw data to building a model, to validating that model, and ultimately deploying it. Machine Learning 2.0 is intended to help companies very rapidly and in a structured manner create new machine learning products in a way that never was possible before. We call it Machine Learning 2.0 because it's a departure from the status quo. Today, many companies approach machine learning projects as research endeavors. This means that the goal is to publish a paper or to create a presentation. However, in ML 2.0, the goal is to create a deployed machine learning model that's impacting how your business operates. Feature Labs is really excited to be part of the MIT ecosystem, as well as ILP's STEX 25 program. MIT has been a core to Feature Labs' work from the beginning, and we're really excited to partner with them again. There are a lot of companies coming out of MIT every year, and we were particularly honored to be invited to STEX 25 and be recognized for the advances Feature Labs is making, taking our technology to market and helping our customers build machine learning models. We were excited to accept the invitation to join so that we could better connect with all of the industry sponsors coming to MIT. The last 3 years at Feature Labs have been focused on taking the advanced technology we developed at MIT and turning it into a product that enterprises could rely on when building predictive models. I'm really excited for the future of Feature Labs because we're working on furthering the automation that's possible in the machine learning process. We can't wait to announce the new products we're working on to help companies go from raw data sets to a deployed model while getting everyone on their data science team involved in the process.